You know, sometimes you just have to admit that something isn't worth repairing. This Amiga 500 Plus, this belongs to Mike. Now, we have looked at a couple of his machines before in the past, but he didn't like to keep asking, and so he thought he'd have a go at fixing this one himself. Just the usual problem: battery damage, broken traces, faulty components. You've seen it all before. I was trying to help him repair it over on the CRG Discord, just trying to talk him through the procedures, and unfortunately he could never get it to work. So I offered, send it over, I'll take a look, see what we can't do to get it repaired. The problem is though that through Mike's repair process, the board has become further damaged, and I just don't think it's worth spending the time on this board, spending the time that it would need to fix this. We do though need to return a working Amiga 500 to Mike. So what I've said we'll do is rescue the chipset off of this and the RAM, and we'll put it all into this Rev 6. Now yes, it won't be an Amiga 500 Plus, but we are going to modify this so that it can accept the 2 megabyte Agnus, and hopefully it will be returned with 2 meg of chip RAM. Granted, this board also doesn't work at the minute, so we need to repair this. This was one I just bought spares of repairs off eBay with intentions of stripping it for parts. It needs an Agnus socket. One of its own RAM chips is missing. In fact, it looks like someone at some point has tried to do a 1 megabyte mod on this. But we'll get to that. For now though, let's take a closer look at this one. So let's just show you what this board does. If we power it up, you just get a black screen. In fact, sometimes you're lucky to even just get a black screen. Sometimes it outputs nothing, not even the sync signal. So something on here is very unhappy. But as usual, the problems all stemmed from the battery, which I'd have to admit, on first inspection here, it actually doesn't look that bad. There are plenty of corroded traces around there, but we've definitely dealt with a lot worse. Now, Mike has obviously had those 3 logic ICs off because they're in sockets there, and as you might be able to see, there is quite a bit of delamination around this one. Not necessarily a deal breaker, but it is quite bad. I mean, I can't flex the board there when pushing it, and there are a couple of vias in that area, so there is a chance that those vias themselves have broke. If you go ahead and just remove these ICs that he fitted here, I believe these are new parts that he did fit. You can see they've got nice long legs on them, but you can maybe see there that there is perhaps some further delamination actually just around this chip. And if I tilt this up slightly, you can see just at that point we have a rather nasty looking blob of solder. There's one trace here that has been patched on the top side, and it also seems as though Gary's socket, it seems as though that must have been replaced. In fact, if I remember correctly, talking to Mike about this, Gary's socket was quite green. That's a new turned socket, so yeah, that has definitely been swapped out. But that's not the only one, because if we just move the board over slightly here, well, the Agnus socket, that has been replaced as well. As you can see, Agnus has been out. She has taken a little knock just in that corner. In fact, I'm not sure what he's used to clean that, but I don't think I've ever seen an Agnus with the writing off it. But let's see if we can get her out of this socket here. Yeah, this falls out because it is a new socket. The chip itself, you can see some evidence on it from where it has suffered corrosion before. In fact, that's probably why the writing is off it. It was probably the corrosion that had done that. You can see a little bit of whiteness in behind some of those pins there. But that socket's been changed, and so has the CPU socket. Another turned socket, and some further evidence actually of corrosion just there at the bottom of the ROM socket. See that sort of white on the PCB. That's the corrosion that this thing was apparently covered in. In fact, if we bring it down to the RAM, you can see more evidence of it there. So Mike just did what we all do. Cleaned it down with vinegar and IPA and then tried to repair the broken traces. He tried to do that though on the bottom side, and unfortunately that's where we run into a couple of problems. So as you can see here, it is a bit of a spaghetti junction in terms of black wires that have been run across various points. Why did he need to do this? Well, some of it is from the battery damage. Unfortunately though, most of it, I would say, is from his repair work, especially where he has tried to remove chips and old sockets. Several pads are missing up around Gary. Same here around some of that logic, and even here over on the CPU. Now Mike is certainly not the first person to lose pads while working on a board. I have done it myself countless times, but I think the reason that he maybe did cause the damage here, or the reason that the damage occurred, should I say, because I don't want to be hard on Mike. You give it his best go, and while, let's be honest, it does look a bit of a mess, I encouraged them to have a go. I would encourage everyone to have a go. I learnt my skills just by doing. That really is the best way. You don't necessarily need to practice on an A500, but do bear in mind that there were, what, 3 or 4 million Amiga 500s made. Granted, the A500 Plus is, I'm not sure, maybe 750,000 of these alone. But have a go. If you make a mess of it, it's not that hard to find another board. You can even get brand new A500 boards. But how do we think some of this damage happened? Well, Mike tells me when he was initially working on this board, he didn't have, at that time, the Moo gun. So he was just using braid to try and free up solder joints where the sockets are. Well, combination of braid and hot air, I believe. The problem with doing that is that when you're using braid, such as this stuff, well, you need to put force onto the board to try and wick up the solder. And even at that, trying to get all the solder out of these joints right through the board is incredibly difficult. So you're putting force onto the PCB, which inevitably is going to scratch it up. It's going to damage those holes, and where there's no traces connected to it, especially on the bottom side here where you're applying the pressure, it is more likely that you're going to lift pads. So I tried to clear the solder from those 2 pins there on Paula, but if we flip the board over, well, you'll not really be able to see it, but I can guarantee you there is still solder on the top side here holding that socket in place. In fact, I can maybe show you better on, say, that logic chip. So let's say if I try to work up the solder from that pin at the end of it. It may seem there on the bottom side that I've got all the solder out of that joint, but if we look at it on the top side here, that is that pin there that I was just trying to desolder, you can still see there is plenty of solder on the top side holding that. If I was to go right around that chip, it may look like it's free on the bottom side, but I would have to wind up trying to pry it off on the top side, or try to pry it off in conjunction with hot air. It's just more likely that you're going to damage something doing that. And ultimately, that's where I think a lot of the damage on this board has come from. Possibly just using too much force with not the ideal tools for the job, and possibly also too much heat. Although I'm not sure about that, because one of the other issues that's quite obvious here is the amount of solder blobs that have occurred when he has been resoldering things. For example, when he fitted that socket, he's wound up with a couple of solder blobs here. Now, usually I find it's the case that solder blobs are going to occur when your iron isn't hot enough. The solder isn't able to flow onto the pin and through the board. I have my iron running at 350 degrees here, and you can see that I just touched that one blob and it has corrected the problem. Might also just be a case, of course, that there's too much solder on the board. But I suspect when he was doing the soldering that his iron maybe just wasn't up to a high enough temperature. That's also evident where we've got large ground planes, say that pin for example, there is a bit of a solder blob there. So again, you are just wanting your iron that little bit hotter just to get a decent flow and to leave you with a nice presentable looking joint. And then the final issue that I want to just touch on quickly here, and again, I'm not trying to have a go at the work that Mike has done. He has done his best, and I can tell you with no doubt whatsoever, I have done an awful lot worse. But the last thing that I want to touch on here is just the patch wires themselves. Now, it's not necessarily the way I would do it. There's nothing wrong doing it this way. I personally just find it very hard to follow. By the time you have, what, 10, 15 patch wires all in one area, it just becomes a spaghetti junction. I really struggle to try and follow where things are going. That's why when you've seen me doing it before in the past, I'm just patching the actual traces themselves, just where the break is. It's very rare you'll see me actually run a patch wire like this. But when you are doing it, one thing you need to watch out for is causing shorts. Now, if we look here, just on Gary, he's fitted the patch wire here, but you can see quite a bit of the inner core of that wire is exposed. And it's very, very close to that pin. In fact, I would say it was maybe touching that pin. That's a short. That's a problem. So I'm just going to remove that quickly. You can see down here on the Agnus socket, he's got even more of it exposed. So we'll remove it from that side as well. And we'll just quickly show you how I would run a patch wire like that. Now, of course, I can't remember what 2 pins it just went to, but we'll just stick it on anywhere here. So I would just expose the tiniest bit of the inner core on the wire, and I actually think this is the same type of wire that Mike had used. We'll then heat that inner core, and you can see there that the outer sheath is retracting up the core there. That's just the heat. It's just causing that to melt away slightly. But rather than work with it like that, what we'll now do is cut that down. And honestly, you only want like a millimeter of it exposed, because we're going to heat this again, which is going to further push that outer sheath back. But we also want to have the wire attached to the pin so that only the outer sheath is visible. The inner core bit that we're making the connection with, it'll all be within the solder blob. And when you're doing this, a little bit of flux goes a long way. So I think it was that pin on Agnus, was it? As I say, it's not overly critical here because this board will never be used again. This is just to show you the process. So a little bit of flux, we'll just put a little bit extra solder onto that pin. We'll offer up the wire. Just remelt that and push everything into position. There we are. Hopefully you can see there that rather than having a big long bit of the inner core exposed that can potentially short out to something beside it, the only thing that you can see there is the PVC sheath of this wire. That would then just be routed across the board up to Gary, wherever it needed to go. I think it was that pin. We'll cut it ever so slightly long. One other way actually to get the outer sheath to pare back a bit, just to expose the inner core, is to put a little bit of flux just on the end of it, and then just heat the end of it. That usually makes it pare back a bit. In fact, I can see a little bit of the inner core there, but sometimes you do just need to grab it and just pull off a bit of the plastic. Then it's just the same thing again. Whatever pin it was, I think it was that one. We'll put a little bit of flux on it, a bit of fresh solder on it, and then we'll make the wire off to it. pushing it into the joint so that once it's hardened, the only thing that is exposed there is the PVC. It's not going to cause any shorts. Now, if you were using an enamel wire, you don't even need to worry about the outer sheath of it really. You can just cut it to length, stick it into the joint, heat it, and the heat of the iron and the molten solder is usually enough to burn off the enamel. I just like using this stuff, and as you can see, I've got miles of it yet to go through. Maybe once this is used up, I'll swap over to enamel. As I say though, it's not necessarily the way I would do it. If we did have a broken trace here and a broken trace here, I would just try to patch it where it is broken and then rely on the rest of the copper running through the board to do the job that it was there to do in the first place. So I think that's enough waffling in terms of this board. As I said, we're going to try and swap everything over to that Rev 6. Yes, I know a Rev 6 doesn't support the 8375 Agnus, but we'll get to that. The first thing we do need to do though is get this working. Now its Agnus socket is broken, so it will need a new one of them, although we might just be able to get away with it for testing. Someone has had a go at the RAM here. Presumably this thing must have had a RAM problem in the past, or someone has tried to do the 1 meg mod, because I think those solder points for the additional chips, I think those are normally filled. And someone has obviously swapped U34 in the past. So I think the first thing we'll do with this board is pull all of this. Let's get the MU gun warmed up and let's get all of that off. A couple of little patch wires on the back of this actually, I didn't notice them before. So there maybe is a little bit of trace damage on this board. We'll inspect it better once we get those sockets and other chips off. But that goes back to what I was talking about a minute ago, the way those wires have been run. The only thing that is exposed there is just the PVC sheath of those wires. None of the inner core is exposed. There's no chance of that shorting anything. And in fairness to whoever done this, all the solder work does look very good. Again, I'm running this thing at 350 degrees today. It's a brand new gun. Well, it's been used a little. Had to replace the old one because it just wasn't getting hot at the very tip. So it wasn't really melting solder. It was just a pain to work with. They're not dear. The replacement Duratool desoldering guns themselves are £24 or something like that. But yeah, enough waffling. Let's get those ICs off. The difference a new MU gun makes is unbelievable. That just lifted out. So yeah, there's a little bit of damage here, which would explain those patch wires that we've seen on the bottom side. But I'm going to try and repair this, just using the method that I normally would. I suspect this happened when those RAM chips were removed originally by whoever was working on this board before it came to me. And in fact, there is actually more rework on this than I had initially thought. Those two 244s, they have definitely been replaced. And there's a trace just at this point, which looks as if it's been patched as well. No signs of any green or anything, you know, no signs of any damage from, say, a trapdoor memory expansion that would have had a battery on it, for example. Sometimes they go bad and can cause problems. So I'm not really sure why someone has had a go here, you know, in terms of changing those 244s, in terms of mucking about with the RAM. My guess would be that this thing was showing a green screen at one point in its past. But we're going to fit sockets here anyway for the RAM. It is very tight underneath the keyboard, but it does just about fit. So we'll fit sockets, but before we do that, we need to make good a little bit of damage. Now, there's one trace there, for example. That hole, that is disconnected from the trace beside it. We should have continuity through to there, which we don't. Much like we do have continuity on that one below it. So must be a break just at that point where the trace is meant to connect onto the hole. So all I'm going to do is scratch off a bit of solder mask just to expose the copper on the top side here. We'll just use a knife to do that. A little bit of flux always helps. Just stick that onto the copper that's there. And then we'll try and tin it up. Now we'll get a bit of our wire We're going to expose quite a bit of the inner core this time. I always just like to cut the end off, because when you strip it, the end of it winds up getting a bit curled. Just cut it off so it's a nice straight line to work with. I'm doing this back to front here. I'm left-handed, but let's see how we get on. Put a little bit of solder just on the iron and try and get that attached there. There we are. So just cut off the wire, and then that bit there, I'm just going to stick it down through the hole. And so once we fit the socket there, we'll make off that wire just onto the leg of the socket, and that's that fixed. No wires trailing across the board. Yeah, granted, in this scenario it's only a wee short wire, but I don't like to see them. I think this is the neater way to do it. There is another little bit of damage we need to fix though, just down here on this trace. Similar problem, although it's broken this time on the left hand side. And that's that one fixed as well. Just before we do fit any sockets, I'm going to go right across this and just test everything. The rest of it looks okay, but I think there were 3 patch wires on the bottom of this, so there must be another joint somewhere. I'll just take 5 minutes here and check it all. So yeah, I thought there was one more broken. It's just at this point. There should be a connection between those 2 points, pin 1 on both those chips, but there's a break just here. Easy to fix though. Let's do the same thing again. And that should be that one fixed as well. So how about we just get all the sockets on. I'm just using these dual wipe sockets. We'll do them one at a time. Just solder opposite corners, then I'll push on the middle of the socket from behind, reflow that just to make sure that it's flush to the board, which it does seem to be. So let's get the rest of those points soldered, then let's get the rest of the sockets done. One down and 8 more to go. Sockets on, and I also fitted the additional decoupling caps, 330 nanofarad caps, although you could use anything, you know, your typical 100 nanofarad caps would be fine. So before we go any further, I want to test things. I've pulled the chipset out of that 500 Plus board and also removed the RAM from it. So let's get this populated. CPU, Denise, Paula, Gary, 2 CIAs, and a ROM. I'm not going to use the ROM that was in that 500 Plus board. It's obviously been a homemade ROM. In fact, it's a 27C800, but 2 of the legs have been cut off it, which seems a bit odd. So instead, I'm just going to use this 2.04 ROM. This would have been in an A500 Plus. But for Agnus, well, we're not going to use this 8375 because we haven't done our modification yet. So instead of that, I'm going to pull an 8372A out of this board, this A2000, which just pretend you never seen because this hasn't been on the channel yet. This is another future project. So we'll stick that to the side and we'll stick this Agnus in here. Oh well, before we do that actually, because this socket is broken, I want to try and brace this with a cable tie, and hopefully it's enough that it gets us going, you know, it's enough to test the machine. The reason I don't want to replace that socket now is because ultimately we are going to do away with it. To use the 8375, we have to use like an adapter board here, which doesn't actually use a socket. Once we get that on there nice and tight, that'll hopefully hold what's left of that socket together enough that we can test this. On the Rev 6, pin 1 of Agnus faces to the right. Yeah, it seemed to go in there. Pretty solid. Let's hook up some wires and see what it does. Oh, well, we need to fit the RAM first, don't we? And we're only going to populate the 512K for now. Power on. Yep, seems to be booting. And there we are. One working Amiga 500. Let me hook up the floppy drive and we'll boot into Amiga Test Kit. So floppy drive ready to go. That's powered up. Yep, still boots. It's trying to seek the drive, so we'll give it a disk. And Amiga Test Kit. Memory. There is our 0.5 meg of chip. And let's just test it quickly. Yeah, that's fine. So how about we go ahead and stick the other 0.5 meg in, bring this thing up to 1 meg. Well, after we do another little modification, it will bring it up to 1 meg. Because if we just put those chips in there at the minute and power it up, green screen. Because what we need to do is a little modification just here at JP2. At the minute, jumper JP2 is connected on the bottom 2 points. What we need to do is cut the little trace there that is making that connection and then join the top 2 points. That's just telling the Amiga that we've got 1 meg of RAM here. So we'll cut through this with a knife. And we'll just test that we have cut it. Yep, no longer a connection there. And instead, I'm just going to put a blob of solder over those other 2 points. There we are. But let's test it now. Hopefully it boots. There it goes. Amiga Test Kit. Memory and 1 meg of chip. So we'll just run a test again and we'll let this go around a couple of times. So that memory test has been round 3 times. I think it's fine. So how are we going to get 2 meg of chip RAM in this machine now? How are we going to use the 8375 Agnus? We just can't drop that in there because this is a different pinout. It is not compatible. What we need to do is build an adapter board, and yeah, this is the bit of the project I'm not looking forward to, because this thing looks like a complete nightmare to assemble. So this is the A500 2000 2 meg chip designed by Liv2. Our Agnus socket will go there. We fit some memory just there to give us the additional 1 megabyte to give us a total of 2 mega chip. But the thing that makes this difficult is that we need to fit pins on this to go down into the A500's motherboard, or well, we're going to fit pin headers on the motherboard to take this. But as you can see, this is all through hole. The first thing we need to do is fit the socket. So once the socket's in, how do we solder the pins? You have to do it all from this side. This isn't going to be easy. So I do need to say a massive thank you to Cathers for providing the kit for this project. They included all the components that we need apart from the pins, but that's fine, I have plenty of those. That's the pin strip that we'll use on the A500 itself, and I'm going to try and use these round pins here on this. And just check the GitHub to be sure. I'll leave a link to this down in the video's description. But there is a build guide on this, and it recommends starting with all the surface mount stuff, so that's where we will start. But in terms of socket and pins, the socket definitely does go on before they do. Just the 1 RAM chip to fit to it in position U2. There's a little blob of solder just on one of those pads there, which I'm just going to clean up quickly. That just allows this to sit flat on the board. I am running really low on flux, so we'll have to be a little conservative with it. I normally do go a bit heavy-handed with the flux, but I've hardly any left. As per usual though, just one pin in either corner to start. Then we'll just inspect it. Of course it's sitting off at a bit of an angle, isn't it? So we'll remelt this side and try to reposition the chip slightly. That looks pretty good now. A little bit of drag soldering should get the rest of that connected. But you've seen it all before, so I'll just fire ahead and get this built. So one slight problem here, I don't have two of the components, U4 and U3 here. A 74AHC1G08, definitely don't have one of those, and a 74AHCT158. So I'm going to have to go and order those, but I think we could go ahead and fit everything else. Now, position VBB, that's not actually listed on the GitHub, or all the parts not listed. It's either going to be a capacitor or a resistor, so I'll just have to go and ask Liv2 quickly what that is. But that is only needed if your 8375 Agnus is the VBB variant of that chip that was used in the A600 and the later A500 Pluses. Of course, we don't know what version of the chip we have because all the writing has wore off it. So I'll leave it off for now. If it doesn't work or if it gives us problems, that's something that we can try. Now, how are we going to do this socket and these pins? Now, socket on first, which goes on this side and goes on like that. Right, I think that's the socket on. And now how are we going to do these things? Future CRG here, I'm just in the middle of editing this video, but rather than make you suffer through me trying to fit these pins, because it was an absolute nightmare, and it's currently about 20 minutes of footage of me losing my mind trying to get these on here, but rather than force you to watch all of that, I thought it'd be better just to re-record this section and give you the very quick version. So first of all, try to fit these using solder paste and hot air. I thought after fitting the socket, the easiest thing to do would be to fill all the other holes with solder paste, set these pins in and heat this thing in an attempt to make that go off. Yeah, that didn't work. All that did was melt all the plastic around these pins, and even at that there were several of them not connected properly, so wound up just removing all of that and just grabbing this in the vise and having to go around every single one of these pins individually with a very fine tip on the iron and using a very fine solder. This is just 0.3 of a millimeter and just doing it all by hand. Even through the process of doing that, I managed to melt things slightly on this side of it. And yeah, it does look a bit of a mess, but there's no way I am removing it to try and just improve the looks of that. This genuinely took about 2 hours to assemble, and I can safely say I never want to do another one of these again. But if I did want to try and make another one of Liv2's boards here, I think I would make the other version of it. Because rather than using a through-hole socket and these pins, the other version uses a surface mount socket. These components are moved out of the way, and on the back you would build a PLCC plug that would just plug into the socket that used to be here. As you can see though, for this project, I have removed that socket and I fitted these pin headers. So we'll pick up back in the video just when I'm actually fitting these. You can see I've also put this second set of pins on the bottom of it, these sort of things, because that's what we're going to make off to the Agnus position on the 500. Just remove that old socket. So this will go on there. And I suppose we may as well just solder that up for now. Obviously can't test this until those extra ICs arrive. They should be here in a couple of days. Right, so I should, in theory then, be able to pull this off now. Wow, that is tight. There we are. And I suppose the reason that I didn't just solder this directly onto the board, I mean, I suppose in reality there's no reason you couldn't just do that. But the reason I haven't done it here is because you could get another PLCC socket like this and just put that into these holes, and then you could use an A372A Agnus again, just with 1 megabyte of chip. There is one other thing that we need though to make the A375 work. We need to pick up address line A20 and bring it to that point. Now we can pick up address line A20 from various locations across the board, but the handiest one is just here on JP5. We can get it from that top left hand pad. I'm just going to use a DuPont wire for that. We'll just cut this down and we'll put a pin hanging out the side of that we can make it off onto. So we'll just strip a bit of that, stick that down through there. There, I think that'll work nicely. So that'll just attach like that. And that is our address line A20. Well, it's a couple of days later. We've got some bits, so let's do a bit of keyhole surgery and try and get them fitted. Luckily this stuff has quite a large pin pitch, so it should be straightforward enough. He says full of confidence and then proceeds to make a complete mess of fitting that component. I'll hit it with a bit of hot air in a minute. That should straighten it out. But let's see if we can do any better with the 158. Yeah, that went on easily enough. Let's see if we can't straighten out that other component though. There, I think that looks a lot better. So this will go in there, but just before that, I found out that VBB there, that's a 100 nanofarad ceramic cap. It is only required though for the VBB version of Agnus. Still can't read the writing that would have been on the top of this one, so all we can do is try it. Power on. Nothing, just a black screen. So I suppose we'll try and fit that 100 nanofarad cap. Try and fit that VBB cap. Nope. Still just a black screen. I'm just noticing here we've got a little bit of chip creep in some of these RAM ICs. They've managed to work their way out of their sockets slightly, just on the off chance. And that's booting to a green screen. Well, I've been screwing about with this for quite a while and not really getting anywhere. Swapped over to this A375 because I know this one works, but still just boots to that green screen when using the original ROM. So try Diag ROM and it boots to a pale blue screen. Never seen Diag ROM do that before. Just like that. Definitely a new one on me, so not really sure what that means. So what's the next step then? Something here obviously is not happy, even though we had this machine, working fine not 20 minutes ago. Well, not 2 days ago as far as I'm concerned. So what I want to try is, remember I said you could put an 8372A back in here if you stuck it in a socket. Well, that's what we've got here. So let's put that in. and see what happens. I just want to rule out whether there's a problem here or whether the problem's on this. Right, we previously had this working fine with that Agnus, so I'm just expecting this to boot. It is booting diagram, but that does not look happy. Yeah, that is very unhappy. So that's making me think that the problem is associated with this. But I don't really see how it could be. And you probably noticed earlier there was a cap missing on this board just there. So I went ahead and fitted that and replaced the one that was there. If we can get this working, I'm going to fully recap the board before we send it off to Mike. At the minute though, I must admit I am a little confused as to what's going on here. Because all of that all looks okay to me. So not unless I damaged the trace when I took the socket off there. But I don't think so. I am half tempted, you know, just to remove those and fit this to the board in a more permanent fashion. Because let's be honest, are you ever going to be removing this again? Well, it's a couple of days later again. This video is definitely long enough, so rather than drag you through everything that I did, I'll just give you the brief catch up. And yes, you might notice here that something looks very different. So I did try it. I did fit this directly to the motherboard, but didn't do anything different. So off it came once again, and this time I fitted this socket directly to the motherboard. I thought I would try the 8372A Agnus in here, just like we did at the start when I'm working on this. But while it would boot diagram over serial okay, I wouldn't get anything out of the RGB. You would get that flashing that you normally get when diagram is starting to boot, but it wouldn't display the menu. I would either go to a static full screen image of a colour, or you would just lose the sync signal. So feeling rather defeated at that point, I decided to go and ask the question of a few guys. And Screamo, he suggested that the socket might be the issue. Now, brand new sockets, in fact I have two of them, the one that Cather sent with the kit, and I had this other one spare. But what can you notice different between those two sockets? That one there, that's an original socket of another scrap A500 board that I had. But that one is quite a bit more chunky than this one. That results in this brown one here being a little bit flexible. You might be able to see it there. Just as I squeeze the sides of it, they sort of bend in a bit. That one doesn't do that. That is rock solid. And so what happens when you fit a decent socket to your 2 meg chip RAM expansion? Well, it just works. Currently booting into sysinfo. And if you look here under memory, there it is, 2 meg of chip. Unbelievable. All that mucking about, and it was just a socket. Not that they are particularly cheap sockets, you know, these came from Mouser, but I suppose any electronics reseller can sell things of questionable quality. It does work now though, and that Agnus does in fact seem to be the VBB version, because I've had it running for hours. I have run the Amiga Test Kit's memory test for, I don't know, 20-30 loops round, and it is rock solid. So the only thing left that I'm going to do, I'm going to recap the rest of the board. Wouldn't usually recap these things, but just given that we don't know the history of this board and some of these caps do have a little bit of damage on them, I think that would be the right thing to do. Well, that's the recap done. Give it a bit of a clean as well, and it's ready to go back to Mike. Now, this is the bit of the video where I had planned on telling you how we've changed our A500 Rev 6A into an A500 Plus Rev 8A. There is one subtle difference, of course. this board has a battery and a real-time clock. This one will never have that. If Mike wants to add real-time clock, he'll need to add something into the trapdoor. But there's also another issue, and I'm sure some of you spotted it while we were working on this board. The chipset that I took off that, well, the knees that came off that, this chip, that is an 8362R8. For anyone not familiar with that part number, I'm sorry to tell you, Mike, but that is not an ECS to knees. That's an OCS to knees. So whoever sold you this board in the first place, I know he bought it off eBay. Whoever sold him this one has unfortunately conned you out of Super Denise. And unfortunately, there's nothing I can do to help there. I don't have any spare chips. Not that there are that many titles that, you know, specifically target the ECS Denise chip. I think everything, more or less everything anyway, will run fine on that one. But if you do truly want to make this an A500 Plus, you need to source the ECS Denise. But it does now at least have the 8375 Agnus and 2 megabytes of chip RAM. Of course, through doing this modification here, the trapdoor slot becomes useless in terms of adding additional memory. And in fact, any additional memory you would plug in there, it just won't do anything. It won't be recognized by the system. The maximum amount of chip RAM you can have is 2 meg. Not that that's a problem though, because I understand Mike is planning to use this board with his Spitfire 500. He was part of the group buy from the boards that I put together last time. And so yeah, I'll get this parceled up. I'll just return this board to him as well. He can continue practicing his solder skills on this. Plus it has his ROM in it there, so I can transfer that over to this board if he wants. I'll leave that 2.04 ROM in there. I've got a couple of them, so I don't mind passing that on. But that's going to be it. Hopefully you enjoyed the video. If you did, I would appreciate a thumbs up. Why not hit subscribe if you haven't done so already? Still plenty more yet to come here on CRG, and I'll see you next time.